Bro, guys, such a no. I have to re-record this video because my other mic died and there's crackles everywhere. This one still has a little bit, so I hope you go deaf, but whatever. Anyway, so yeah, we'll be doing this problem, but before we start this problem, normally I won't have an intro, but today I will. And essentially what this intro will have is like what normal videos of problems, me doing problems will be like. It'll just have a picture of the problem in a diagram, and then after I show that, I'll give you some time to read it, and then I'll outline my solution, normally followed by like intuition on how I thought of it and what led to it and stuff like that. And if the problem is good enough, then I'll give computation, like actual numerical or symbolized computation afterwards. Yeah, so let's get started. So hopefully you already read this problem, just pause it and read it if you haven't. And yeah, so the first thing you have to notice is rolling without slipping, and that means the condition of v equals r omega. This is pretty much all you need in pretty much every rolling without slipping problem. Another thing you have to notice is how long, so you have to parameterize these variables in terms of time somehow, like somehow get everything in terms of time. And so yeah, let's get started. So let's first notice that this ball starts off with a speed of v naught, and it starts off with an angular velocity of 0, or speed, whatever. And then we notice that friction is slowing this down. So let me use red for this. While friction is speeding this up. And so, yeah, so we just have to find the median where 0 increases to a certain point while v naught decreases to a certain point, and we just have to find the amount of time for it to reach that median where this equality is satisfied. Should be pretty simple. First step for this solution would be to use kinematics and put everything in terms of time. Yeah, I'm just gonna put time t abbreviation for putting everything in terms of time. And step 2 is just to solve algebra. Should be relatively simple. Okay, so let's get started. I should probably split this up. One way is kinematics, other way is torque and angular kinematics. I'll improve this for the next video, don't worry about it. Anyway, yeah, let's get started. So step 1, let's put this left side in terms of time first, velocity. And so essentially, we know that the velocity after a certain time t is going to be the initial velocity, then minus the acceleration, then times the time. So acceleration is going to be mu g. This is the frictional force that's deaccelerating the object, negative mu g, and then being multiplied by time. This is one of the basic kinematics equations that you should know. And yeah, the next thing we have to notice is the omega. So to find how fast it's accelerating omega, we have to use torque. Torque equals I alpha, which means that, I'm gonna write this somewhere else. Alpha equals torque over I, and we know that the torque is due to the frictional force mu mgr, then over the I, which is 2/5 mr squared, and this comes out for alpha being, I believe, 5 over 2 mu g over r. And so this means that we can just use the same exact kinematics equations and get that the omega after a certain time, t is going to be the omega initial, which is 0, then plus this angular acceleration, which is 5 over 2 mu g over r, then times t. So this is the second part of our step 1. And now that we have these two conditions right here, we just have to plug them into this equation and solve for time. Easy as that. So let's do it. Once we plug it in, we should get mu v naught minus mu gt equals 5 over 2 mu g, I have to make sure I read this right, over r times t. And this whole thing is being multiplied by r. And you can note the similarity. This is yellow. This is gray. And it's just being multiplied by r. And so once we solve out, we should get that t equals 2/7 v naught over mu g, if I did my algebra correct. And this should be our final answer. Thank you for watching, and more videos will be coming, so stay tuned.